In these next two examples, we're going to look at using that percent change formula, but as opposed to figuring out a value on an intermediate step, we're going to talk about how you can string them together and figure out an overall value at the end. So let's take a look at two examples so we can kind of see what that looks like. Now in this first one, it says for 3 consecutive years, the tuition of a university increased by 15%, 12%, and 14%. What is the overall percentage of increase of tuition over the 3 years? So in this one, we can't just add these percents, because when this 12% increase happens, it happens on whatever that amount was that resulted at the end of the 15%. When this 14% increase happens, this 14% increase is going to be on whatever that amount we would get after we applied the 12% increase and the 15% increase. The base changes halfway through the problem. Actually, the base changes every time we go to try to figure out one of these new percents. So the only way you would be able to add these percents is if every one of these percents applied to the same base. Because it doesn't, the cost of the tuition changes from year to year, we're going to have to do something a little bit different to figure out what's going on here. There is where our percent change formula comes into play. So again, the percent change formula that we're using is this. So let's first do the tuition after the 15% increase. So at that point in time, so this would be then after the first year, the tuition is going to be given by 1 plus, and then because it's a 15% increase, it'll be 0.15. And then I don't know what that starting amount of the tuition was, so maybe I'll just leave it as x. We're actually going to find that it really doesn't matter what the initial part of the tuition was. We can still figure out what this percentage of change over the 3 years is. So this is what it would be after the first year. Maybe if I go ahead and just clean up what's inside the parentheses here, I would get 1.15 times x. Okay, so that'll be after the 15% increase. Now let's take a look at what's going to happen after the second year. After the second year, I'm going to get a 12% increase, so that would be 1 plus 0.12. But it's a 12% increase on what it was. So this is the expression to represent what the final amount is after the first year. So this is going to then represent a 12% increase on what the tuition was at that point in time, which is given to us by the expression 1.15x. Now at this point in time, I'm going to go ahead and clean up what's inside the parentheses here. So I would get 1.12, and then I'm going to multiply that by 1.15, and then my x. All right. I'm purposely not going to multiply this stuff out right now so we can kind of see a pattern of what's going to go on here. So this represents first doing a 15% increase, and then on top of that, then doing a 12% increase. So then after the third year, I want to do a 14% increase, so 1 plus 0.14, and it's going to be a 14% increase on top of what it was the previous year. Well, at this point in time, this is my expression for what I had going on the previous year. So then I would have then this copied down. So cleaning this part up, then I would get 1.14. And then the variable x. So then now I'm going to go through and I'm going to multiply all this stuff out. So if you were to multiply this 1.15 times 1.12 times 1.14, we will end up getting 1.46832, and then the variable x. Okay, so here's how all this relates to each other then. If I come over here and I use this inside of my initial formula, so I just figured out the final amount after these 3 consecutive increases is this. So 1.46832, and then x, is equal to some percentage of change right here with respect to what the starting amount is, and the starting amount for what the tuition started at before all this changed is what we would call x. I could divide both sides at this point in time by x. So if I were to do that, the x's actually wipe out on both sides. So then again, we're seeing that it doesn't really matter what these initial tuitions were. So I have 1.46832 is equal to 1 plus p. Subtracting 1 from both sides, we get 0.46832 is equal to p. Moving this decimal over 2 spots then, we end up with a 46.832%. And then because this is a positive number, we would say increase. So increasing the tuition by 15% and then by 12% and then by 14%, whatever that final tuition is, represents about a 47% increase based upon what it had started at. Okay, so in these types of problems, sometimes it's helpful to maybe not do all these intermediate multiplications so we can actually see what's going on here. So there's my 15% increase, followed by my 12% increase, followed by my 14% increase. Overall, then once I get this, I can then compare what this final amount is with respect to the starting amount and figure out what percent increase that would be then represented by over these 3 years. Let's take a look at a different problem, kind of utilizing that same idea. So it says a toy store buys a certain toy from the distributor to sell during the Christmas season. The store marks up the price of the toy by 80%, which is the intended profit margin. Now, unfortunately for the toy store, the toy is a bust and doesn't sell well. So after Christmas, it goes on sale for 40% off the marked price. After a while, an additional 25% markdown is taken off of the sale price, and the toy is put on the clearance table. Now, with all of these markups and markdowns, what is the percentage profit or loss to the toy store? So for this one, so whatever the toy store buys this toy for from the distributor, we're going to let that be x. So let x be the, let's say, purchase price from the distributor. Okay. So if they were to buy it for X dollars and then sell it for X dollars, now they're not going to make a profit, right? They'll break even on the toy. So let's see what happens to this toy through all of this stuff. So first off, the store will mark up the price of the toy by 80%. So after the markup, so maybe we'll keep track of what's going on. So after the markup at this point in time, the price of the toy is going to be 1 plus, there's my 80% markup, and the markup is going to be with regards to whatever that original purchase price was. So now the price of the toy then would be represented by this expression. So there's my 80% markup. Now, for the toy store, the toy is a bust and doesn't sell, so it goes on sale for 40% off. Okay, so now it's going to go on sale. So on sale, this is then I'm going to, because this is going to be a decrease, I'm going to subtract 0.40 from 1. And then it goes on sale with respect to what the selling price of the toy is, which is right now represented by this expression. So this is the selling price of the toy, and then this is going to represent my 40% off. Again, on this one, perhaps we don't want to clean up and actually do some multiplication, so I'm just going to clean up what's in the parentheses here. So this would be then 1 minus 0.4 is 0.6 or 0.60. So if you wanted to leave all these zeros in here so you can see these percentages, this 80 and this 40, you're welcome to. But really, I don't need these trailing zeros. So this means if I mark it for 40% off, I'm then going to pay 60% of, and I'm going to pay 60% of the 1.80x. So at this point in time, this represents the sale price of the toy. Now again, the sale price, the toy doesn't move, so now it goes on a 25% markdown. Okay, so we're going to maybe call this the clearance price. Alright, so for clearance, it's going to be a 25% off. So 25% is going to be represented by 1 minus 0.25. And I'm going to mark it 25% off of whatever this sale price is. So the sale price is being represented by the expression 0.6 times 1.80x. So at this point in time then, this gives me 0.75 times 0.60 times 1.80 and then x. Okay, so now it's sitting right there on the clearance table represented by this expression. So now that we're done doing all of our markups and markdowns, now let's go ahead and multiply that stuff out. So if we multiply this, we get 0.81x. Okay, so if we come back to our percent change formula, so F is equal to 1 plus P times B, we just found that the final price of this toy is 0.81x. So 0.181x equals 1 plus P, and then B, the original price, was represented by the variable x. So again, I could divide both sides by x. Here's again where we're seeing it doesn't really matter what this price was because we're figuring out how much the percentages changed. So I would get 0.81 is equal to 1 plus P. To solve for that P, we're going to subtract 1 from both sides. And when we do that, we get negative 0.19. So what is this representing to us in terms of the percentage profit over loss? Well, first off, the fact that this is a negative, it represents a loss, and it's going to be a loss of 19%. So we would ultimately usually report that as a 19% decrease, but we're going to report this as a 19% loss. So what we just found out is after all of these markups and markdowns, they're going to be selling this toy at only 81% of what they had originally paid for it. So they're not going to get 100% of their money back. They're only going to get 81% of their money back. Well, in that case, that means they're taking a 19% profit loss on that toy.